Welcome to The Explainer. You've seen it in movies, you've seen it on the news. It's that little box that can change a life in an instant. But what's really going on inside? Today, we're going to crack open the surprising science, the hidden history, and the legal battles behind the breathalyzer. Yeah, this is the alcosensor. It's that device you see at traffic stops, right? It measures what's called breath alcohol content, or BAC. And in the few seconds it takes to get a number, it can set off a chain of events that changes a person's life forever. You know, we tend to think of it as a simple pass or fail thing, a clear line between legal and illegal. But the truth is, the story behind this little box is way more complex. And to really get why, we've got to go back in time. Way, way back.
So, you probably think breath testing is a pretty modern invention, something that came along with cars. But nope, the quest to measure alcohol on someone's breath is actually surprisingly old. We're talking nearly 150 years ago, back in the era of gas lamps.
It all kicked off with a simple scientific observation, way back in 1874. But from there, it took about 80 years to get to the device we recognize today. And the path to get there was, well, it was a little weird. And yes, you are reading that timeline correctly. One of the earliest tests literally involved having someone breathe into a football bladder.
And get this, in the early days, the device wasn't just for the police. As this quote from Popular Science shows, one inventor actually imagined it as a tool for housewives to check if their husbands had been out drinking. Talk about a different kind of sobriety checkpoint. So this thing was called the drunkometer, and it was one of the first practical tests. It was also incredibly low-tech. A driver would blow into a balloon, and that air was then bubbled through a chemical solution. If the solution changed color, well, you had alcohol on your breath. Crude, for sure, but it was a start. As you can see right here, these early machines were a far cry from the sleek, compact devices police use today. So how did we get from these clunky contraptions to the modern sensor? Well, the answer lies in some pretty clever chemistry. Okay, so what's actually happening on a chemical and electrical level when someone breathes into one of these things? How does it turn just a puff of air into such a precise number? All right, this right here is the single most important thing to understand. A breathalyzer doesn't actually measure the alcohol in your blood. It measures the alcohol in your breath, your BRAC, and then it uses a mathematical formula to estimate your blood alcohol content, your BAC. And that one step, that conversion from breath to blood, is where almost all of the controversy begins. So, the most common sensor today uses this fascinating piece of science, an electrochemical fuel cell. Think of it like a tiny battery that's literally powered by alcohol. When you exhale, any ethanol on your breath kicks off a chemical reaction that creates a tiny electrical current. The stronger the current, the higher the BAC reading. It's elegant and it's really fast. The science inside the box seems pretty solid, right? But here's the problem. It isn't analyzing a sterile sample in a lab. It's analyzing a breath from a living, breathing person. And the human body introduces all sorts of variables that can dramatically change the final reading. You would think a breath is just a breath, wouldn't you? But it turns out the answer to this is a surprising yes. The way air moves in and out of your lungs can have a huge impact on that number you see on the screen. Take hyperventilating, for example. One study showed that if you breathe really fast for just 20 seconds right before the test, it can lower the result by as much as 10%. Why? Well, because you're clearing out the deep lung air that holds the most alcohol. And yep, the opposite is also true. If you hold your breath for 30 seconds before blowing, you can increase the reading by over 15%. That extra time lets the air in your lungs absorb more alcohol vapor, and that could easily push a borderline reading right over the legal limit. And it's not just breathing patterns. There's this big issue called mouth alcohol. See, the machine is designed to measure air from deep in your lungs, but it can be fooled. A recent swig of mouthwash, and some of those are almost 27% alcohol, can cause a massive false spike. Even something as simple as a burp can bring up alcohol vapor from your stomach and contaminate the sample. All this variability is exactly why so many myths have popped up about how to beat the test. So let's just ask the big question. Is there any truth to them? Can you actually trick a breathalyzer? This question became so popular that the TV show Mythbusters famously dedicated a whole segment to putting some of the most common urban legends to a scientific test. The results? They were pretty decisive.
Sucking on pennies, eating onions, holding a battery in your mouth, all completely useless. The device is measuring a chemical reaction, not just smelling for alcohol. And mouthwash? It didn't just fail, it actually raised the reading. Every single myth busted.
So if the test has all these variables and all these potential points of error, how does it hold up as a core piece of evidence in our legal system? Well, the legal system addresses this by using two different tests. The small, portable device you see on the roadside, that's just a preliminary screening tool. It only establishes probable cause for an arrest. The real test, the one with results that are admissible in court, is a larger, much more accurate machine back at the station. And to sidestep that whole complicated argument about converting breath to blood, states created what are called per se laws. This was a total game changer. It means that driving with a beer AC over the set limit is, in itself, the crime. Prosecutors don't need to prove you were impaired, they just need to prove the number on the machine. Look, the breathalyzer is an indispensable tool for keeping our roads safe, but it's also an imperfect one where biology and chemistry can create doubt. And that leaves us with a critical question. When a machine's reading can be influenced by something as simple as how you breathe, how much power should that single number really hold over a person's freedom?